Hey students, it's me, Mr. Fitz. I'm down here in my basement making another video. This time, this video is on the greatest common factor. So buckle your seatbelts. Let's take a look. I'm just going to share my screen with you really quickly. All right, here we go. Greatest common factor. So I have no idea why I chose a picture of the moon for this. It has nothing to do with greatest common factor. I just took this picture over the summer. I thought it was really cool. Anyway, hope you like it. All right. Here's an example problem. What is the greatest common factor of 48 and 60? So whenever I see a problem like this, or even a problem with an algebraic expression or something like that with variables in it, I think about breaking a number into its prime factors, because prime factorization, numbers prime factors, that's the fundamental theorem of arithmetic. Every number has its own distinct set of prime factors. So if I can find the prime factors, I can compare them and then find the greatest common factor. So that's what I'm going to do. So I know you've seen factor trees before. So 48 is it even, so it's divisible by 2. So I can say 2 times 24 is 48. And then I can break down this even further, right? 24 is 2 times 12, 12 is 2 times 6, 6 is 2 times 3. Now you can do this a different way, right? You could come up with a different factor tree, but you're going to always get this distinct set of prime factors. 2 times 2 times 2 times 2 times 3. You could get them in a different order, but remember just multiplying them together, and multiplication is commutative. So either way, that it's always going to be that set of prime factors for 48. Now let's look at 60. Now you could have done this a different way too, right? So I said 2 times 30 is 60. I could have said 2 times 15 is 30 here, and I would have gotten the same set of prime factors. But I said 3 times 10, and then 2 times 5. Either way, I'm going to end up with 2 times 3 times 2 times 5. Or I could write that as 2 times 2 times 3 times 5. So these are the prime factors of these two numbers. Once I have this, I can use this and use a Venn diagram to figure out the greatest common factor. So let's take a look. So here's a Venn diagram. A Venn diagram, all it is it's two overlapping or two interlocking circles, two intersecting circles, and it creates a little intersection here. And what I'm going to do is I'm going to compare the common elements, the common prime factors in these two numbers. Notice they both have two sets of 2's in common, right? So they also have a 3 in common. I'm going to go ahead and put those right in the intersection there, because that's what they have in common. Now on the yellow side, I'm going to put those leftover 2's right there. And on the right side, I'm going to put the 5. So basically everything inside the yellow circle, if I multiply these numbers together, I'm going to get 48. If I multiply these numbers together, I'm going to get 60. But what if I multiply this intersection together? What does that give me? That gives me the greatest common factor. 2 times 2 times 3 is 12. That is my greatest common factor. So now you could use a calculator and start, guessing, checking your way to see if plug in a bunch of numbers that are divisible. What is 60 divisible by? What is 48 divisible by? You could create all of the factors of them and look for the greatest one. I just find this really useful and fast way to find the greatest common factor. And it works for algebraic expressions. So let's take a look. 32x minus 28, and I want to factor this. So this is an example problem from Delta Math. So 32x, well, I can factor that. I can say that's just 2 times 2 times 2 times 2 times 2, or 2 to the 5th power times x. And 28 is 2 times 2 times 7. If you don't believe me about this being, this factor is like, this is the prime factor, well, what is x? X is just a variable representing a number, right? So let's use a factor tree. Well, 32x is just 32 times x, but I can't factor the x, it's just an x. If we're x squared, I could factor it, it could be x times x, but it's not. So 32, that's 2 times 16, and then 2 times 8, 2 times 4, 2 times 2. So here we go. 2 times 2 times 2 times 2 times 2 times x. And then we have 2 times 2 times 7. Well, we can use our Venn diagram approach again. What is in the intersection? 2 times 2. That's my greatest common factor. What's over here on the left? Well, the leftover 2's, these 3 2's multiplied together, and then an x. What's on the right? a 7. Well, how am I going to use that greatest common factor to factor that? Well, factoring is just dividing, right? So I'm just going to factor out, or I'm going to divide out a 4 from both of those terms. So I can rewrite that expression as 4 times, what is 32x divided by 4? 8x. What is 28 divided by 4? 7. So it's just 4 times 8x, don't forget the negative symbol there, minus 7. Here's why the Venn diagram is also so great. Look at these numbers here on the left. What is 2 times 2 times 2 times x? 8x. There's my 8x. There's my 7. There's my 4. 4 times 8x minus 7. 4 times 8x minus 7. So I really like this approach. Hope you do too. If you have any questions, please let me know. Otherwise, I'd like to thank all of you for watching my video. Have a great rest of your day, and I'll see you next time. Peace.